Hey guys, so it's April 21st. Today we're going to do a little bit of trig, which isn't too scary. We're going to introduce it in some small ways, and then we're going to be using it for the rest of the week, I think. So in the past, we've used the Pythagorean theorem to find missing lengths of right triangles. Now we're going to find trigonometric ratios using right triangles and finding angle measures and right triangles. So some new vocabulary is trigonometry, we got some ratios, sine, cosine, tangent, and then inverse sine, inverse cosine, and inverse tangent. You guys probably don't know what any of these words mean yet, but we'll introduce them and hopefully get you guys super comfortable with them. Okay, so these are our ratios that you're going to become very familiar with. We'll just start with sine. So over here we have this right triangle ABC, and our angles are labeled with capital letters and our sides have the lowercase letters. So if we wanted to find the sine of angle A, we would take the opposite side over the hypotenuse. So that in this diagram would be A over C. So A is opposite to that angle that we're talking about, and the hypotenuse is always that angle that's opposite of the right, or the side that's opposite of the right angle. So now if we wanted to find the sine of B, it's still the opposite over the hypotenuse, but notice that we're talking about side B now, because that side B is opposite from angle B. Okay, so now for cosine, if we take the cosine of A, that ratio is going to be the adjacent over the hypotenuse. Now if we look over here, we have angle A here. So we have two sides that are adjacent, right? We have C and B that are adjacent, but remember that C is the hypotenuse, so we want to look at B, which is that other adjacent side. Now if we find the cosine of B, okay, A and C are both adjacent to that angle, but C is the hypotenuse, so we're looking at the adjacent side A over the hypotenuse C. Okay, now the tangent. The tangent is always the opposite over the adjacent. So if we're finding the tangent of A, we need the opposite and the adjacent, so we would have A over B. And then for the tangent of B, again, opposite over adjacent, so now our opposite is B and our adjacent is A, so then we would have B over A. One way to remember these ratios is SOHCAHTOA. Mr. Knudsen, do you teach that?
I do.
Okay. Oops, that's supposed to be an O. TOA. It's just a word that helps you remember the order. So if we're finding the sine, we want opposite over hypotenuse. If we're finding the cosine, we want the adjacent over the hypotenuse. And if we're finding the tangent, we want the opposite over the adjacent. I still use this to this day to help me remember what they are. So that will be your friend. So let's start applying some of these. Okay, so we're given a right triangle over here, LMN. We have to express sine L as a fraction and as a decimal to the nearest hundredth. So we have to pull from those ratios that we were talking about. So the sine of L would be the opposite leg over the hypotenuse. So here if we have L, its opposite leg would be this 12, okay? And the hypotenuse we're given is 37. So we go ahead and plug in these numbers. So our fraction here would be 12 over 37, but they also want it as a fraction, so that you just do on your calculator really quick and we get 0.32. So the answer is written in the fraction form and the decimal form. So now we want to find the cosine of L. Well, the cosine was the adjacent leg over the hypotenuse. So here we have L still. Okay, our adjacent now is this 35, and our hypotenuse is still 37. So when we go ahead and plug in those segments, we get 35 over 37, or when we find the decimal, we get 0.95. So that would be the cosine L. Now we're finding the tangent of L. So the tangent, is opposite leg over the adjacent leg. So here we have L, opposite here is 12, and our adjacent here is 35. So go ahead, plug those in for those segments. So we get 12 over 35, or 0.34 for the tangent. Okay, now we're going to start looking at angle N. So to find the sine of N, still the opposite leg over the hypotenuse, but now we're looking at it from a different angle. So we have N, this will be our opposite, this 35, and our hypotenuse is this 37, so plug those in. So we get 35 over 37, or about 0.95 would be our sine of N. Now if we found the cosine of N, we have the adjacent leg over the hypotenuse. So here's our hypotenuse, here's our adjacent leg. Go ahead, plug them in. So we get 12 over 37, or 0.32. And lastly, we have the tangent of N. So that's the opposite over the adjacent. So here we have N, our opposite is this 35, and our adjacent is 12. So go ahead and plug those in. So the 35 over 12 in a decimal form is 2.92, and that would be the tangent. So here's some for you guys to try at home. We're finding the sine of A. Okay, so we have A here. All right, sine, SOHCAHTOA, that would be the opposite over the hypotenuse. So here's our opposite, 12 over the hypotenuse, 20. So we should have 12 over 20, right? Notice that none of the answers say that. We need that fraction in the simplest form. So that 12 over 20 would simplify down to 3 over 5. So you guys should have gotten B for this one. Okay, now we're finding the cosine of A. So that's the adjacent over the hypotenuse. So our adjacent is this 16 over the hypotenuse is still 20. So we have 16 over 20, which simplifies down to 4 over 5. So you guys should have gotten C. And lastly, the tangent of A. So here we have A. We need the opposite over the adjacent. So we have the opposite, 12, over the adjacent, 16. Put that into a fraction and it'll simplify down to 3/4. So you guys should have gotten A. Okay, now we're going to look at that angle B. Okay, so first we have to find the sine of B. So that's the opposite over the hypotenuse. So we get 16 over the hypotenuse, 20. Put that into a fraction, simplifies to 4/5. So you should have gotten C. Okay, now the cosine of B. Alright, here's B. We need the adjacent over the hypotenuse. So this adjacent one is 12 over the hypotenuse, 20. That simplifies down to 3/5. So we should have gotten B. And one last one, we're finding the tangent of B. So here's B. Remember, the tangent is the opposite over the adjacent. So here we have the opposite is 16, adjacent is 12. Put that into a fraction and we get 4/3. Okay, so now we're going to use the special right triangles that we did earlier in this section in this chapter at some point. So we have to express the cosine of 60 degrees as a fraction and as a decimal to the nearest hundredth. So first, let's draw a triangle. Okay, and we're going to plug in those numbers that we know about the special triangles. So if this is our 30-degree angle and here's our 60-degree angle, our short side is x, our long side was x square root of 3, and then the hypotenuse was 2x, remember? So it's telling us to find the cosine of 60 degrees. So if we found the cosine of this 60 degrees, cosine is the adjacent over the hypotenuse. So x is our adjacent, 2x is the hypotenuse. I think if I go to the next page, it'll show you that. So then when we simplify this down, we get 1/2. And 1/2 in a decimal is just 0.5. So the cosine of that 60-degree angle would be 1/2 or 0.5. Okay, so here's one for you guys to try. We can refer back to that last picture if we want. So we're finding the tangent of 60 degrees. So let me just go back to it really quick. Oops. Okay. So now if we're finding the tangent of 60, okay, here's 60. For the tangent, we need the opposite over the adjacent. So our opposite is x root 3, and our adjacent is x. So if we go back to the next page, we should be finding that x root 3 over x simplifies down to root 3 over 1, because those x's cancel each other out, so we should be getting c. And when we find the decimal, we get about 1.3 or 73. Okay, so now we're kind of applying this stuff into some real world situations where we find triangles in real life. So we have a fitness trainer sets the incline on a treadmill to 7 degrees. So that's that little angle down here. The walking surface, the hypotenuse here, is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill from the floor? So we want to know what this y is. Okay. So letting the height be y, remember it's asking us how many inches, but here they give us feet. So we have to do a little bit of converting. So the length of the treadmill is 5 feet. When we multiply 5 by 12 for the 12 inches in a foot, we know that the hypotenuse is going to be 60 inches. So to set this up, we take the sine of 7 degrees, and remember the sine is the opposite over the hypotenuse. So we plug in the 7 here, and our leg that was the opposite was that y. That's what we're looking for. Okay, and the hypotenuse we know is 60 inches. Okay, so when we're solving this, we just want to multiply both sides by 60, and we can find y. Now to use your calculator, let me grab this one. We would write it out just like this. So the way that we should enter it is we should have 60, and then sine, it's 2 buttons above your 7, and then a little parenthesis will pop up. We want to put the 7 in the parentheses because we're taking the sine of that 7 degrees. Okay, and then we press enter, and I got the wrong thing, but you know what we need to do? Go into your mode. It's up here by your second button. Make sure that you're in degree mode. That's why I got the wrong answer. In this class, we'll only be using the degree mode. Some of your calculators might be in radians right now. You'll use that in different classes, but in this class, we're just going to be using degree. So I don't know if you can see this, but we want to be in degree mode. So then if we type that into the calculator in degree mode, we get this 7.312 blah 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 number. So the treadmill is about 7.3 inches high. That's how much she increased it. Okay, so here's one for you guys to try. The diagram's already drawn for you, which is kind of helpful for you guys, I think. So we have the bottom of a handicap ramp is 15 feet from the entrance of a building. If the angle of the ramp is about 4.8 degrees, about how high does the ramp rise off the ground to the nearest inch? So we want to know what this height is. Okay, so we're given this 4.8, and we need to find the opposite, and we're given the adjacent. So it looks like we're going to be using tangent with the opposite and the adjacent. So we would have the tan of 4.8 equals, and this is where we set up that ratio, so we have the opposite over the adjacent. We're just going to call this x over 15. Okay, now to solve this, we have to multiply each side by 15, so we get 15 times the tangent of 4.8 equals x. And And now if your calculator is in degree mode and you go ahead and you type this in, 15 times tan of 4.8, we get 15 inches. Oops, I did something wrong, didn't I? We have to convert this 15. Because we're looking in inches. Miss Higgins goofed. So we would have 15 times 12, which is 180. So we would actually need 180 times the tangent of 4.8. Okay, so now we're introducing inverse ratios. So we're going to talk about the inverse of sine, inverse cosine, and inverse tangent. We use these because, throwback to Algebra 2 that you guys did earlier this year, when you're dealing with matrices and you want to divide by a matrix, it's not possible, right? Instead of dividing by a matrix, we would multiply by its inverse. So that's kind of how we undo these trig functions. So the inverse of sine is written as sine, and then it's like up to the -1. And you can find that on your calculator by using the sine, cosine, and tangent buttons on your calculator, but it's in blue above that. So we would want to write second sine if we were finding the sine inverse. And cosine and tangent. Okay, so we'll just kind of apply those. So it says use a calculator to find the measure of angle P to the nearest tenth. Okay, well here we don't know what this is, so I'm just going to call it x. Okay, now we have to look at what numbers are given to us for which legs. So it looks like we have the hypotenuse and we have the adjacent. So I think we're going to be using the cosine. So we would write this as the cosine of x equals, then we plug in our ratio here. So we had the adjacent over the hypotenuse, so 13 over 19. Okay, I think if we go to the next page, we'll have that. Okay, so we have that. Now we need to find P. We don't want the cosine of P, we just need P. So that's where we use the inverse of cosine to get what the measure of an angle P is. So to use our calculator, we would just type it in as the inverse cosine like this. So I would press second cosine, and then 13 over 19. And I got 46.8, and that's what we should have gotten. So our measure of that angle P is approximately 46.8. Okay, here's one for you guys to try at home. They drew a diagram for you, which is really nice. So we have to use the calculator to find the measure of angle D. So angle D is here. Okay, and as always, we want to look at what's given to us. Okay, so it looks like our opposite was given and the hypotenuse was given. So we're going to use the sine because the sine is the opposite over the hypotenuse. So if we call this measure of angle dx, I would say sine of x equals the opposite over the hypotenuse. So we have 16 over 23. Okay, so now to take the inverse of it, to solve it, we would have the sine inverse of 16 over 23. And when we go ahead and plug that in, we go second sine and plug in that 16 over 23. I got about 44.1, so we should have gotten A for this one. Okay, this is our last example, and this is kind of the fun stuff. So we have to solve the right triangle. So what that means is we have to find all the angles and all the sides. So they give us this one angle, the right angle, which is kind of neat. So we know that we still need to find the hypotenuse. Okay, and we need to find the measures of each of these acute angles. So it says round the side measures to the nearest hundredth, and the angle measures to the nearest degree. So as always, I keep saying this, we want to look at what they give us. So here, if we just start with angle A. Say we want to find what that is first. We're given the opposite and the adjacent. So it looks like we would use the tangent. And I think they're going to use that on the next page. Yeah. So if we go ahead and plug in those numbers, we get the tan of A, tangent of A, is equal to 4/7. But we want to find the measure of A. We don't want the tangent of A, so we take the tangent inverse of 4/7 to find that measure of angle A. And we get 29.7 blah blah blah. So we're going to round that to the nearest degree it said, so we're going to call it about 30. So now what we could do is we could use these trig ratios to find the measure of angle B. But what we know is that angle B and angle A were complementary angles because we had that other right angle. So if we take the measure of angle A plus the measure of angle B equaling 90, we could sub in this 30 degrees for measure of angle A, which we just found, and then we would find that the measure of B was about 60 degrees. Okay, so now we still have to find that missing side, our hypotenuse. And that we can just use the Pythagorean theorem to solve that. So we had AC squared plus BC squared equals AB squared. AB was the hypotenuse. So we were given 7 and 4, so we go ahead, plug those numbers in, and we get 65 equals AB squared. So our actual hypotenuse would be the square root of 65, or about 8.06. Oh yeah, they wanted decimals. So then your answer should be written in this form. You write all the things that were missing in the original triangle. So we found the measure of angle A and the measure of angle B were 30 and 60 about. And then the hypotenuse, that segment AB, was 8.06. Okay, so here's one last one for you guys to try at home. They give us a diagram here. So it says solve the right triangle. All right, let's just start with finding B first. Okay, so we're given the opposite and the adjacent. So just like that last one, we're going to use the tangent. So if we have the tan of B equals the opposite over the adjacent, so we have equals 8/11. Okay, now to kind of undo this, we would take tan inverse of 8/11, and that will give us the measure of angle B. So when we do that in our triangle, I press second tan, and then type in 8 divided by 11, and I get about 36. Okay, so if the measure of angle B was 36, we could just take 90 minus this 36 to give us A. So when we do that, I can't do things in my head this morning, we get about 54. So it looks like so far we can get rid of this option and this option. So we know that the measure of angle A is 36. The measure of angle B is 54. Now we have to use the Pythagorean theorem to find that missing side length. So, show my work over here. If I called this A and this B and this C, then I had A squared plus B squared equals C squared. Okay, now I can plug in these side values that we have. So I have 8 squared is 64. Plus 11 squared is 121 equals C squared. Okay, add those together, we get 185 equals C squared, and I don't think that's a perfect square, is it? So we're going to take the square root of 185, and I got about 13.6, so looks like A.
You had B 36 initially.
Oh, Mr. Knudsen's correcting me. I just crossed out the wrong ones. B was 36 and A was 54, so that was not an option, and that was not an option, and that's the right side line. He's giving me the thumbs up from his desk. Okay, so hopefully that wasn't too much for you guys. We're going to do page 573. We're going to do 17 through 45 odd. As always, please let us know if you have any questions. We really want you guys to get this stuff before we move on to the next sections and apply it even more. Good luck.